thanks everybody for coming in. I'm sure more people will join as we progress, but it's time to kick this off. So I'm Jacopo. I'm the CTO and co-founder of Bauplan, and I'm like so pleased to lead this fireside Zoom panel chat, whatever you want to call it, with Matthew, Paul, and Simba. They're all good friends of Bauplan. Again, they've been picked because they're like incredibly handsome and they're like mildly competent about the topic of today. We'll see how handsome you can just judge from the first 5 seconds. But at the end of these 40 minutes, we're all going to judge how competent they actually are. I'm the least competent person of this all, as I definitely, data practitioner. I'm sure you're familiar with Bauplan, kind of like, agentic data infrastructure. But we are not a semantic layer provider. And, we want to invite people that spend a significant amount of time in the professional career at the highest possible levels, all jokes aside, to think about these problems and and see how they see this new world with agentic data and how that intersects, of course, infrastructure and all the other places. So I will ask anybody to go around and do like a 2 minutes overview, like previous episode in your life. Let's say, if people missed this Netflix series, what did you do in the previous series? And why you end up in this call with us, and then we can start hopefully disagreeing on most points and see who wins. Okay, so I'm gonna just call the names because I have you in my Zoom. So Matthew, can you go first, please?
My name is Matthew Mullins. I'm the CTO and co-founder of Coginiti, where I'm responsible for both product and engineering. Before this, I worked at another company in the semantic space called Coginiti. And before that, I was a philosopher studying epistemology and cognitive science. I have a background in linguistics and the cognitive world, which I left academia to go back into data. So,
fun fact: all 3 founders of Bauplan met at a philosophy undergrad degree into that. I know how many people.
There you go.
Awesome.
How many people know that? But I was a mediocre logician, and then Ciro and Mattia, then one went to study decision theory. I went to study kind of like cognitive sciences, and Ciro went to study neuroscience. But we all come from the same background, which I think is like a lot in common with Matthew, which is why I know the meaning of epistemology without Googling up, which is great. Paul, you go second.
I can go next. So I'm Paul. My background is like technical data science, studied, language models back in 2017 when the Transformer paper was coming out. After that, started Zenlytic. And what we do is we're trying to solve like the last mile of data, make data accessible to business teams. So I can talk a lot to our kind of evolution, and my experience in the semantic layer is building one as trying to serve the last mile of data to those business people. And then my kind of, coming to this moment on, I don't actually think that's the right way to do it now, given the kind of capabilities that we see with agents. So a little bit of my background and change in perspective.
That's awesome. And you're young enough, you say. I was doing language modeling. I think you're trying to impress us with 2017 as kind of like going back in time.
In AI years, that's forever. AI years are way faster than dog years.
I was doing language model when there was like HMM, Hidden Markov model was a language model. So a complete different era of language model. The original Claude Shannon modeling. And Simba, the same for you. Thanks so much for joining us from a spaceship inside of the Enterprise. Yeah.
From the Zurich airport. I am Simba. I'm the head of AI products at Redis. I was formerly the founder of and CEO of a company called FeatureForm, which is a feature store. So I've been building semantic layers since before LLMs were a thing. Redis recently launched Redis Iris, which is our full agentic suite, which includes context retriever, which is very, very similar to a semantic layer.
We're going to get into this similarities in a second. Okay, thanks so much for the introduction. The first thing I want to do is, which is semantic layer is paradoxically, you need a semantic layer to define a semantic layer if you just Google a bit. As everybody has a slightly different definition of what a semantic layer is. I would recommend an article, which I think has been written by Matthew. There's like 3 different definitions of semantic layer. That I really like because it started with Marvin Minsky, and again other things that all the people that cares about cognition actually care about. But I will ask you, Matthew, maybe if you can just give let's say as objective as unbiased perspective you can do as a small definition of what you think a semantic layer should do, what's the use cases, and what are the main components. and then we can see, how we can evolve this into the era of agent. Let's pretend it's 2025, Matthew. Okay, let's pretend it's 2025. Okay, cool.
I think that a semantic layer, if we go back to foundations, we're going to go back to like business objects, right? And so a semantic layer was designed to give human readable names to database objects, right? So historically, databases, 50 years ago, you had like an 8-character limit on a column name or a table name. So we had all these cryptic names. And, unless you needed a data dictionary constantly to navigate that. And in the evolution of self-serve analytics, we gave this mapping of like business terms to these database object terms, right? And so that's what the original semantic layer did, was it gave the meaning for those terms that were found in the database. I think in 2025, not only does it need to give a meaning, it also needs to sit in the operational path of the data. That is, that when you're using the semantic layer actually connects you through to the data as well, so that any kind of query or anything like that is actually interrogated through the semantic layer. And so I think those are like critical components of it, is to have that mapping. And what that does is it gives you all of the entities, the dimensions, the facts, and the measures are all encoded into that semantic layer, and the relationships between those. And so how a table relates to each other. And so when we're dealing with humans or we're dealing with agents, it gives them guidance on how to join those tables, how those measures are related, what's the appropriate grain, things like that. And in modern semantic layers, it also gives you things like synonyms, so that like that sales and orders mean the same thing. It also gives you full descriptions. And so we're starting to see like some convergence between like the ontology sense of a semantic layer and our traditional BI semantic layer come together in universal semantic layers.
I think that's great. I mean, I said 2025, but I think at some point we were in 1989 or something like that with the 8 columns, HR columns in the database. Yeah. But that's amazing. But let's say if I play back to you guys, like, it's a fair understanding. We have like 2 components. One is kind of like, in the traditional sense, and then we can go in the new world, but like the one side we have definitions, and as you said, facts, dimensions, how to join stuff and all of that. But another component is how to actually operate on the data, as in, I don't just tell you what this column is, but given a request, I will compile or transpile or create a SQL that will actually generate the tuples, the data, the results that you have. Like, is this like a fair kind of like, summary? You guys think I did a good job? Cool.
I agree.
Okay.
Yeah, I love it.
So 2025, that was an amazing year, and I think we're like a fantastic year. Now 2026. So most important thing is that the Knicks are the NBA champions. But second most important things is that now actually agents are everywhere. Sorry, Matthew, please.
Second most important things is that the Canes won the Stanley Cup.
Oh yeah, fair. I'm sorry. Like again, I'm such an NBA fan, and everything else kind of like in proportion, kind of like is dwarfed by by this fact. And a New Yorker, of course, like an adopted New Yorker. So park Knicks aside for a second, way more interesting topic, and go to AI for a moment, which is what we're discussing here. So, and I will ask Paul maybe to say, hey, you are a big proponent, because I've seen a few public talks of you on this topic of changing this, or at least evaluating if this thing that we just said, amazing as it is, should, must, will be disrupted by this new interactive pattern with agents. And so I want to give you a chance of like, how do you see these things in this new world? And can you give your perspective, of course, based on your experience and kind of like, client perspective also in the everyday life of your company?
Yeah, definitely. My perspective changed on this dramatically, right? Because I started out being like, hey, you need, like, the first talk I gave at an AI council way back in 2023, and like the pre really big language model days, was basically that you need a semantic layer to work with language models, like to work effectively with data. And my case there was basically, well, the models aren't accurate enough, and they don't have the context on what they should be doing for net revenue to begin with. So because of those two things, you need the semantic layer to sort of enforce accuracy and to make sure that the model actually knows how it should be calculating net revenue. The thing that changed my perspective on that was constantly serving, some of the world's largest companies, and realizing that all the questions that business people wanted to ask kept on bumping into kind of limitations of the query compilation side of the semantic model. So if you think of let's take LookML, maybe the most recent broadly successful semantic layer. I think we can agree on that as LookML is the most recent sort of broadly successful semantic layer. You can put in measures, dimensions. You effectively send those to a query compiler. Out the back end comes SQL. If you want to start doing more sophisticated things with CTEs, if you need to union tables together for some reason, any of the more complex SQL operations you want to do, you very quickly can't do it in Looker. You can't do it via LookML. And then typically what happens is a human kind of bypasses that. They know the LookML definitions. They go, they write the SQL, and then they come back and they say, hey, here's the actual answer. Sorry, you couldn't get that answer in Looker. So there's inherent limitations to flexibility if you rely on the...
Sorry, just to that everybody's agree on the workflow. What you're mentioning is in the world when there's like only structured information, which is very powerful, very ontology pilled, so to speak, as the kids say these days. It's great when things work, but it's not as flexible in the edge. Like there's always something in the long tail of need. And so what you say that a human bypass it, what you mean in a real company that there's an analyst, I guess, that takes this request from the business and then does an ad hoc analysis. It takes days or hours or weeks or whatever, and then it comes back to the user. So it's not just that this is a bypass, but in practical terms, it's really a drag on productivity for the company. Is that a fair description?
Yeah, definitely a fair description of what's happening. The other thing that I would say really, so you could always have argued that initially. And I think initially I would have said, well, you probably don't have that many questions that need to go outside of the semantic model. But as the capabilities of the underlying language models and agents just get better and better and better, people ask bigger questions. Domino's is one of our customers. There's CMOs coming in asking like, hey, should I be offering a $5 or $8 discount on this next promotion? We all know that's a super, super sophisticated question. That is not just like a, group this by that kind of thing you can stick into LookML. It's very, very sophisticated. So it's like you definitely need the context parts of a semantic model. The agent needs to know how to calculate net revenue, but I would say you don't need the query compilation components, not with the agents as good as they are today, because they need to know how to calculate net revenue, but you want the agent to act more like a human in this instance, where they can answer whatever question you could reasonably have asked a human to answer. Like you shouldn't limit the agents to only some subset of questions based on the expressivity of the interface that you're giving them. You should give agents, and I think we've seen this from the agents that have been really successful, like Claude Code, you should give them simple tools that are languages and frameworks that they already know how to use and let them be as expressive as possible in that environment. So context, yes. Query compilation, no.
Isn't that a technical limitation of the particular semantic layer? So that's like a technical feature. So I'll give you an alternative example, which is that our semantic layer, which does encode, all the metrics and join conditions, but it also supports semantic SQL. So you can write fully expressive SQL against the semantic layer and submit that. So it supports CTEs and things like that. Anything that you can write in regular SQL gets submitted, and it goes through our internal parser to generate the SQL on the other side. So it gets regenerated into whatever the platform SQL is, but it's just as expressive as regular SQL is. The difference is that it has measures baked in to that as well. So you have the ability to use those measures, and it has the known join condition specified. Whereas I think the traditional semantic layer didn't do that. You picked selectors to then have it generate the SQL. Whereas I know a number of modern semantic layers, at least in 2026, support, semantic SQL against the platform.
Yep, that's a great point. And this is something that I view as an asymptote. So it's kind of like if LookML is over here being less flexible, semantic SQL is more flexible. There's inherent, there's some inherent structuring that you're doing in the semantic SQL that will make it less expressive than SQL. It's an asymptote, right? It's like you have the semantic interface, and some of those are less expressive, some of those are more expressive, and it asymptotically kind of goes to completely raw SQL, where you can do actually anything the database lets you do. And I think there's two components. One is that since it asymptotically approaches SQL, and the agents just continue to get better and better, I would say SQL is the best move. The other component to that is that agents perform much worse on DSLs, like domain-specific languages, versus on languages that have massive, massive amounts of training data. So whatever your semantic SQL syntax is, the agent is going to perform a little bit worse on that than it will on generic SQL because SQL is like the third most popular programming language in the entire world. Whereas, whatever our LookML or, whoever's semantic syntax is always going to be, there's going to be less density of training data. The agents, like the labs, aren't going to do reinforcement learning on our own DSLs. So the agent's performance will drop actually pretty materially. I can share a link to some stuff on this if it's helpful. But the agent's performance will drop pretty materially whenever you're using a domain-specific language that's not a mainstream language.
But semantic.
Sorry, one sec. Before we go into that, because I have the actual mother of all questions of like, how do we trust the SQL that things generates, and which I think is like the other. I think is that like you described, like a Paul, like a one-dimension kind of like line, but of course I think it's there's always like a trade-off of like, well, but there's a trust component to it which goes in the other direction, and that was the sweet spot. But it's also a question that's been asked, and I'm actually, it's one of my favorite questions these days, and I want Simba to try and guide us through this word, and is people talk about semantic layer, maybe BI data engineering. People in the AI engineering community talk about context layer, which I think is also the official Redis name for some of this offering. And I think a lot of people are asking themselves, and by a lot of people, I mean, starting from Jacopo, is like, are we just saying this? Are AI people reinventing for the 10 times something that everybody else was using with a different name? Or there's a different nuances between what you guys see as the context layer in Redis and your product roadmap, and what the traditional BI people sees as joins and metrics and all of that, and where are the similarities and differences, like that you see Simba like every day?
Yeah, I think it helps to take a step back and think of what semantic layers aim to solve. At its core, it's allowing non-deterministic access and understanding to data. The idea was pre-LLMs. That was essentially what data analysts did all day. They'd look at your Snowflake instance and they'd non-deterministically answer questions, join things, use data. If I told you pre-LLM, but I was going to put a semantic layer on top of Redis, you would think I was insane, rightfully so, because there's no good reason to do that. I think a lot of like the SQL, the raw SQL question falls back to, if I gave you access to my Snowflake database and I told you to figure out what our ARR was last quarter, it would take you a really long time to even just figure out what the hell you were looking at, what this data means, what these tables mean. Like there's probably like 45, tables that have the word customer in it that you'd have to be able to parse through. So what the semantic layer does is it lets you think in terms of business objects. I have users, I have items, I have delivers, I have orders, I have these concepts that has you describe it to human. So why it's really powerful, and we're kind of quote unquote reinventing it for agents, is really just agents. Even though agents use tools imply action, but actually like 90% plus of tools are really just data retrieval tools. And for many, many, many use cases of agents, you don't want every data retrieval to map to like a Spark job or a Snowflake query. So you want the ability for the agents to be able to think, hey, I need to, this user asked me, why is my order late? I need to go figure out what the hell a user is, what an order is, what am I looking at, and navigate this data, the semantic layer, to get the data that I need. Whether that's in Snowflake or Redis or whatever, actually, it doesn't have it, in my opinion, has nothing to do with what a semantic layer is, which is really a business mapping to concepts.
Do you still see about like as Redis, as you said, like a few years ago this will sound ludicrous and whatever, and now it actually doesn't. Do you think that this is because Redis, of course, is like super low latency, super high concurrency? Like, do you think that the agentic access pattern, it what makes Redis or tool like Redis like a kind of like incredibly suitable to play this role in a modern architecture versus what it was the previous era? Do you think that's the kind of edge that the Redis ecosystem brings to this, aside from the concept itself?
Yeah, I mean, what you'll do is like, so the semantic layer, if you start with it, you'll end up with this idea of, I create the semantic layer, I'm going to map it to all my systems of record, which could be Salesforce, it could be Snowflake, it could be all these different databases. What you're going to find is over time, you're going to want, for many, many use cases, again, for like a end user facing use case, you're going to want something fast. It might not need to even be Redis fast for some use case. Let's say you're like, I'm going to use Postgres. Eventually, you're going to create a read replica. You don't want your agent hitting Postgres directly. Then you're going to say, oh, these indices don't exactly map to how an agent's going to interact with this thing. So I'm going to actually create a materialized view. And then eventually you're going to end up with, I'm going to create a materialized view in Redis of my data. And so we see really often, in fact, we saw this pre the release of Redis Iris, that we would have teams take systems of records, build this kind of materialized view of context, and provide that to the agent through MCP, CLI. In fact, very recently, I'll share here that we prototyped and will soon release an A-to-A interface where you actually talk to a librarian agent to be able to actually know how to interact with the semantic layer and work that way. But yeah, I think the reason why Redis is a data delivery. In many ways, it's data delivery, and it's not a system of record, and now for agents, we're seeing it being used for context delivery and memory, which maybe we'll get into too.
Yeah, we go back to, also, distribute, like, as a person that really likes correctness and distributed system, the first question I would ask to you, but I'm not going to do today or now, is, well, but if now I have a materialized view in Redis and the actual source of record is in object storage or whatever, how do I guarantee that the actual data that I see is consumed fresh or joinable in a consistent way? Incredibly interesting question, just because I ask it, but we're not going to get to that. I want to go back to one of my favorite topic about symbolic logic and versus neural network, which is neural network very flexible, as Paul, graphically kind of like, picture this asymptotic, where in 2 years from now, or probably less than that, LLMs will write the best SQL on the planet. And that's amazing. I never liked to write SQL. I also think Paul said that SQL is a programming language, which is an incredible compliment. That's amazing. And then Matthew was like, kind of like, wait a sec. There's, we don't have to accept immediately, like, this whole idea of, like, free form generation. Maybe there's something in between. And my worry, and then I bring it to you, Matthew, is like, do you feel that as the model become very, very good, we're just not going to need any SQL checks, any trust, like relationship, any of that? Or do you think that the power of ontology will actually be scaffolding this generation in a way that makes the business user trusting? Because one thing I know is that the only thing worse than not having an answer to the question of the domino coupons is having an answer that is wrong, but that it looks plausible. So what do you think, Matt? What are you seeing? Where do you draw the line, or do you have an idea where this line is moving?
So we do think that, like, I think that a lot of times the importance, like, I can grant that agents are really good at writing SQL, and they're getting better at writing SQL. I do think, though, that, like, I think of the semantic layer oftentimes as a governance layer, right? So not only is it telling you, like, what the standard measures are in the company. So we want everyone in finance to use finance ARR. We want people in sales to use sales ARR. We want to be able to tell the difference between those. But even in the SQL generation, and this is the thing I've seen and I worry about, like, when you're just raw dogging the data with your agent, is that when you go through the semantic layer, we have to solve for things like fan out and chasm traps and all these kind of, like, bad queries that can be written. And even, like, really sophisticated SQL writers sometimes fall into these traps. And so your agent will write queries that are, syntactically correct, and they will pass, and they'll actually run the query, but they will return numbers that are way off, right? If you fall in a fan trap, right? So you get a bunch of duplication, so your counts are way off, right? There isn't anything in the path. So semantic layers, all of them, from, Click, and, every modern semantic layer has had to solve for these kind of query compilation problems. So even when you submit the semantic SQL, we can catch those and correct those to make sure that, like, what you're writing is actually valid SQL. And so I do think that even, you need some kind of validator. So a lot of times it's not even about the SQL generation so much as, like, that check that happens in the pathway for the semantic layer to make sure that those things are happening. Because if you don't understand the SQL, if you're a business user who comes in and asks a question in this, like, AI for BI world, and it goes out and generates a query, you don't understand the query. You don't know about cardinality and things like that. You don't know about grain. You're just looking at a number that comes back, right? And so I think that semantic layers actually promote that, like, higher level of accuracy, and making sure that those things aren't just semantically correct, but they're actually they're semantically and syntactically correct.
Can I shift things, like, can I bring, some kind of Bauplan perspective on this, in the sense that, like, some of the things you mentioned, shouldn't they be, open question, shouldn't it shift a bit left? Like, if I look at the word for a second from the Bauplan perspective, like building good tables that don't have duplicates, that have a very, code first, kind of like, built-in semantics, in a sense, generated by agents or humans or whatever, would that, let's say, ease many of this concern, in the sense that if I unleash an agent over tables that have been well prepared and well kind of like maintained, and data quality is there, wouldn't that make, like, the check kind of like catching this error way before we get to the final stage? Or you think, Matthew, this is really the point of the errors that you see in the
No,
world?
it's a question about query construction. So even if you have great tables, if you have, two tables, with a one-to-many, you join those the wrong way, you've got a fan trap query, and now you've double counted everything, or you've massively, you've got this giant Cartesian join now.
Yeah.
So those things can happen even with like beautiful tables, well modeled. You have this excellent Kimball model that you've deployed.
Yeah.
You can still fall into these like query compilation errors, and the semantic layer can catch those. Or if you have some kind of validator, you need some kind of validator in there.
Paul, do you
Yep.
see
So-
this? Do you see this changing in your asymptotic picture? Do you see this? Let's say, poorly written queries, with good intention, but poorly written queries kind of like getting better in your day-to-day life, or you see these errors still popping up in your customer?
Yeah, so I would say there's like three things there. One, it's like I totally agree with Matthew, even on purely like beautiful, well done tables. If you've got two fact tables, you can easily create a chasm or fan trap joins in those scenarios. So that's going to happen regardless of how good your data infrastructure is. So it's like, there's no kind of like do a better job at the front way to get out of this problem. The other thing I would agree with Matthew on is that the trust component really matters. So it's like, you've got to have a way to explain to the user what happened, without them having to look at some 800 line SQL statement that the agent wrote. So you have to have some understanding of the query, but I don't think that should mean you can limit what the agent can do. So I think the difference in perspective between me and Matthew here is that I would say you should be able to help the user interpret the query and understand what the agent did. What existing concepts did it reuse? What new stuff did it do on the fly that's maybe different or hasn't been done before? So you should help the user interpret the query and understand what it did in business terms. But the thing I would disagree with actually is that you need this validation component. I think the validation component, by its very nature, is always going to impose some restrictions on what the agent's able to do. Some of those will be well-intentioned, but the agents are so capable that maybe in late 2025, they were still making a bunch of fan out, chasm trap, join mistakes. They're probably still making a few of those now. But if you play this forward to we're on Fable 6.5, like they are far superhuman in all coding aspects. Like they're already winning gold medals in programming competitions. There's no humans basically who are consistently better programmers than language models, even at the current level right now. So I think there's kind of, the models just aren't going to make mistakes the same way. They're going to be much more consistent than your absolute best analysts. So give them the fullest access possible. And then it's like, the problems you need to solve are like, how do you interpret this to someone? How do you make sure the agent has the right context to know what to do in the first place? Like those are the kind of problems that you need to solve around the same sort of problem statements that the semantic layer used to solve, because the problem statements still matter. It's like, how do you map business terms to stuff that sits in a database? How do you help a user understand what business terms they're looking at in a report? It's like those problems still matter, but I think they're solved differently in an era where you have agents that are just so superhuman, it's ridiculous at coding.
I think is a very valid kind of view of the future. With with a few caveats that I would do. But I would ask Simba if we take Paul words at the face value for a second, and you say, okay, now agents are becoming superhuman. They solve, programming competition. If they solve programming competition, how complex your SQL can be. To be honest, again, it's SQL at the end of the day. But now, how do we manage this? Become an engineering problem from a conceptual problem. Like, how do I manage, for example, all this context? How do I manage all these entities? Like, I know of people that have, customers that have like hundreds of thousands of tables, and even if for a magic token, we can put all this context of semantic of these thousands of tables inside a model today, it will probably not do a good job. Not because the model cannot, as we said, is very good at reasoning. Not because our tables are not well documented. Let's assume they are, to Matt's point. But maybe there's an engineering bottleneck here that requires a different way of thinking. Is the memory layer that people talks about on Twitter the solution to this? X.com. So I'm a boomer and it shows. But like, is that what we're looking at, Simba? Or the memory is a slightly more nuanced concept that just not clogging all the context with kind of information we don't know if we need?
Yeah, I think so. I'll play back my take on what Matthew all have said. I agree that agents will be able to write better SQL than humans if they don't already. I think that's true. I would love to live in the fantasy world where we have clean, perfect data, where any real enterprise has, clean, perfect tables that actually exist and are well documented. I've yet to see it, and I've seen many, many enterprises' data. So the reality is that we're always there are two. I used to say this with ML. We probably talk about this Jacopo, where it's like there's two problems that are unsolvable: the data problem and the evaluation problem. And we got into agents, and the two problems that remain unsolvable are the data problem and the evaluation problem. For the data side specifically, when you think of what a data analyst does, it's understanding the business, having hypotheses, testing those hypotheses, and SQL is just a means to an end. It's just a way to join data to be able to kind of visualize and actually answer the hypotheses to some extent. Will an agent be better than me at coming up with these hypotheses and storytelling? Will I trust it with no guidance? I don't think so, not anytime soon. I don't really see a path for that. I don't think they're really optimizing for that. I don't think I don't think economically that's what Anthropic is whatever is determined to solve. So I think that is what they're doing. When it comes to the memory layer, what we see with a lot of people building, specifically like the BI agents, is like a human, a data analyst. The thing that people forget is every time an LLM works, it's really an input and output. The context window has an output. So it always starts from scratch. And so a lot of the goal is how do you give it what it needs so it doesn't actually have to start from scratch. Semantic layer is part of that. It doesn't have to go and run all these queries, figure out what the hell am I even looking at. And the other part of it is memory can be useful for it to be like, oh, I've seen this before. This is the table that I have to go look at to solve this kind of problem. Or, oh, last time someone asked me this, I ran this query and I solved that problem. So I think we get really caught up in like, what is the right way to write SQL or whatever, but I don't think that matters. That's not really the problem to solve. The problem to solve is how do we answer questions with data, and given data will always be messy, at least in my view. I don't think that's going to get solved. And every single company is going to have it differently, have their own intricacies and nuances. We will always need some form of agent that is able to learn from decisions. We'll always need some form of semantic layer. Whether it's writing semantic SQL or SQL doesn't actually matter to me, but there needs to be some way for it to quickly understand what the hell it's looking at and what it means.
Yeah, I think there's if I can help it, I think there's a really good point in there, is that it's like the agents will always need a way to store and like manage context so they can actually learn from an organization. I think there's sort of two surfaces or two things that serves. There's just concepts that would be kind of undiscoverable. It's like, Joe in accounting happens to know something because he's been here for 20 years. And it's like that previously would have been undiscoverable. The agent's got to be able to find that somewhere in documentation. The other purpose that it serves, like gathering all that context, is that it's a shortcut. Like there was a really good question from Jason Taylor in the chat of like, will we ever get to the point where an LLM is smart enough and has access to be able to discover and learn semantics without a layer? And I think definitely not in all cases. There's a lot of cases where there's just no one knows that information is not written down anywhere. But there's a lot of cases where, given a large enough amount of time, if the agent can look at your Tableau dashboard and run a query and look at the Tableau dashboard again, run a query, eventually it can back into how are you calculating these things that you care about. And the agents are very persistent, and they just can increasingly run on longer and longer trajectories. So a lot of times they'll be able to, given enough time, figure out the answer to your question. But that trajectory is on the scale of hours, and most people don't want to wait hours. So once the agent has figured that out, it needs a way to be able to store that information so that the next time it just searches in this context layer and wherever it stores its context, and is able to say, yeah, that's the gotcha that took me 3 hours last time. Now I can just go solve this problem in a matter of seconds or minutes.
I think moving from stateless to stateful, so to speak, is like humans, the first day on your job, your interns need to learn everything, and then the second week, hopefully, you don't have to explain that all over again. Well, that depends on the intern actually for humans, but you get the idea. But we're discussing a lot about the read path, right? So semantic layer, and can the system figure it out? Can it store it between sessions? And now we're going this future where the agents figure out new concept, starting from content that exists and maybe giving them into a knowledge base that another user can use it, call it memory, call it a better semantic layer, whatever that is. But the question that somebody's asking on the chat, but also the question, of course, is very dear to my heart as a person that writes more than read, is who watches the Watchmen? Who established a semantic layer in the first place, right? Because now we're assuming that somebody has done the semantic layer for us, and the only thing we do, quote unquote only, is query validation, query compilation, and all that. But in the first place, when do we write this information? Is this, as we think, next to the code? Whoever generates the code that generates the table needs to sort of pair it up with semantics? Is the business user that use another tool of authoring, like a business catalog, on top of the data engineering? How are we thinking about this? Is this a specialized agents on top of the data engineering agent that does it? How are we seeing that? Matthew, do you see the right path?
Yeah. So our platform is built for data engineers and for analysts to both work into it. We started out as a collaboration tool, and we actually have an agent for this. And so the agent, especially if you have well-modeled data, can mock out a semantic layer fast. It can generate it from the physical, and it has rules around giving it real names. The thing that the agent can't do is it can't tell you what your metrics are. Right? It can't tell you how you measure ARR. I mean, it can make a proposal, right? It'll make something up. It will definitely generate, any kind of measure that you want. Whether that's the one your business actually uses or not, someone has to validate that. So you have to have a human in the loop. And so we have a collaborative way of doing that where people can come in the platform, everyone can look at it, they can agree that, in fact, that is how we measure customer and product. That's the way that sales thinks about customer. And those may be different, and we may work those under different domains. And so agents can act as accelerators. They can't do it end to end. They can't implement the full semantic layer because they just don't have enough. They don't know your business the way that the humans in your business do. And a lot of times you have to get the humans in your business in the room to nail out an agreement on what that is. But the idea is that then you get that and it's governed, and now you have that consistency, right? You have that consistency across the organization so that when a business user comes in and asks a question on the semantic layer, they get consistent results across the org.
A bit of an implementation question, but how does the process gets actually carried on? Meaning that now we have a semantic layer, but we have the data. Correct me if I'm wrong, Matthew, your platform works on top of Snowflake, Databricks, whatever it is. You don't do the data infra, you're on top of that. And so now, how does this process not drift, for example, from whoever is writing the Databricks or Bauplan jobs? And is this also a process like code when you version the definition of your semantic layer, and now if the definition changes, your query change proportionally into that? It's a hard topic, but I just want to get you a high level thing of concept changes in time. And now if concept changing very fast because the world is moving faster, are we not making all our life harder by having this middle layer into this?
There's a lot packed into there, but one of the things that we do version everything that's in our semantic layer. That means that we version during the development process, but we also have the concept of a release, right? So the semantic layer gets promoted into production, and so we have a release cycle. And so you can actually look and see what was the version of the semantic layer. And we did this from version 1 of our semantic layer because we have so many customers in regulated industries. And so they need to be able to go back and say, this question was answered on version 26.2 of the semantic layer. Can I roll back to that and see how we calculated the measure, 2 years ago, 3 years ago, 7 years ago. All those release versions are captured. And so we have that whole production life cycle. We have the semantic life cycle built into the platform. And we also have, in terms of like drift, we also have assertion testing capabilities. So we can see like, is this metric still within range of what it was expected? Is it still returning a result? Is it suddenly null? And so as those releases get pushed out, we actually have a test suite that runs against those as well.
That's very cool. Does it also work in the point in time travel? So for example, if I query, can I query a metric like as it was last week, or like there's like an API to do that, or okay,
You
or
can, because you can, yeah, because you can see you can go back to the various versions of the semantic layer through the API. Yeah.
Okay. So in your experience, let's say the people that there's no real drifting, or the drifting can be minimized between the right path of the database, Snowflake, Bauplan, whatever, the actual code that runs and create the tables and the semantic thing, you think the good tooling will reduce or possibly even eliminate this drift?
Yeah, good tooling.
In a practical way. Paul, have you seen the same problem with your customers, same challenge of like semantic drifting away from the actual underlying infrastructure? And did you solve it similarly? The match, which seems to be very code focused, as in this solution seems to be very inspired by coding best practices. Do you see something similar in your work?
I think I'm maybe a bit more agent pilled on trying to solve this more with agents. There's got to be a human in the loop to verify like that this is actually corresponding to the kind of information you want it to correspond to. But I think agents can take a much larger share in the initial kind of setup and ongoing maintenance of the semantic layer of the context that the agents use. Reason for that is that pretty like every single company, any company of reasonable size, is already going to have not just one, but many different reporting products, like ways that they consume data. You can take screenshots. You can connect Power BI via MCP. You can give, in our case, our agent, access to those underlying systems. Then you can tell it, figure out what the underlying like metadata is. And the agents are relentless. They'll go and they'll look at your Power BI. They'll run some queries. They'll be like, oh, I guess I must have missed a filter there. They'll run some more queries, look at the Power BI, run some more queries, look at the Power BI. They'll do this stuff that took humans months to do. And the agent can build your semantic model. Is it going to miss stuff? Or are there going to be things that it doesn't know that only someone in some other department knows? Definitely. And it's going to have to ask the human for collaboration in building that. But it can massively accelerate the amount of time it takes to build out this context, because you can put them in a loop between what would the human have done. The human would have done and looked at the dashboard that the CEO looks at, and checked to see that the numbers are the same. That's how you know you're not going to get fired. So the agent can do the same thing. On the ongoing maintenance of it, the drift happens in a few different directions, actually. So I think it's like a bidirectional drift instead of a unidirectional drift. There's the drift with the underlying tables. So like whenever possible, we would rather inherit the context from the database. So like we do that for Databricks, Snowflake, BigQuery. Like when most enterprises, it's not actually present on the tables. It'd be great if it was. Most of the time it's not. We would love to inherit that. If we can't inherit it, then we need to build it through this kind of look at your Power BI structure. But there's another form of drift that can happen, which is the business changes. Like the kind of questions the business people ask and what they expect actually does change. And then you need a human in the loop to address that change. You don't want an agent just, a business user says, actually, I'd rather see it this way. Then it goes and edits your model. So it's like you need really good observability tools for the data team, the data engineers, analysts, to be able to look at what are the questions that are coming in. Those are starting now to not meet the user's expectations in the same way. What do we need to change about the model? And the agent needs to then be able to make those changes. So I think there's synchronization with the underlying database, which is important, but there's also what the business users actually want will change. And you have to have observability for the admins to be able to see what's going on and make those changes.
I have to say that you mentioned Database Snowflake's tables. You forgot to mention the table that comes with all this information you can use, which is the Bauplan tables. So
that's right.
I'm making way, spend you way less tokens and do way less work that you need to do with other platforms. Sorry, it's like a small plug. But on this, I want to give everybody on the chat the opportunity to ask more questions, as we're like, time flies when you're having fun, with friends, even without talking about NBA basketball. Let's just talk about semantic layer. So we need to wrap up soon. But the last question, as you guys, if you want, send some questions in chat. But I want to ask one last questions to give people more time to think. To Simba, as Paul was painting this picture of like, so Matthew was like, okay, a bit of human and a bit of agents. And then Paul was saying, instead of garbage out, garbage in, garbage out, is like agent in, agent out. Everything's an agent basically. And we're gonna be out of things to do very soon. And that's amazing. But who's paying for all of this, Simba? Like, Paul is querying Query BI, like Query BI and Snowflake 25,000 times because it doesn't want to do these things anymore. And Snowflake is gonna happily, and Database is gonna happily bill you for every time you do so. Plus, Anthropic is gonna happily bill you for all times of this. Is there a role of intermediate representation, so to speak, that will also start to address this problem? Because up until now, I think it's fair to say that everybody was fine. It's like, yeah, we're experimenting with token. But if you look around, people are already starting to kind of like go back. It's like, okay, yeah, but there's a limit to this. Plus, I don't want to pay the token and Databricks. Again, I don't want to be overpaid to overpay twice. Like, maybe I can overpay one of this, but I don't want to overpay twice. And so, what's your feeling, especially as kind of like a historically caching, kind of efficient caching gear in the Redis as an ecosystem?
Yeah, I mean, there's a lot here. So one is everything we've been talking about is semantic layers for BI. Actually, at Redis, most of what we're thinking about is not that. Semantic layers for more kind of end user facing use cases where, again, you're not going to let a user say some natural language that's going to map to a SQL query, unless you really, really don't like data privacy. So what you'll find is it makes a lot of sense where you can start to think of here are the common sorts of use cases that we're going to deal with. Not that you have to think of every use case, but hey, if I create a materialized view that has these sorts of aggregations, these sorts of concepts, and we give that instead to an agent, one, it's going to be a lot cheaper. Two, it's not going to be able to accidentally run up some massive Spark or Snowflake bill or Bauplan bill or whatever. It's harder to Bauplan, of course. So yeah, I mean, we're going to see a lot more about it. And it's going to be even more common, especially when you're, again, like, let's say you have someone I'm at a network. So you have someone who's at a game and they have a question. Do you really want them to be able to write a question that can transform into a really expensive Spark query? Probably not. You probably want to have some pre-built aggregations that they can hit. So yeah, we'll see a lot more about the other two things that really help. One is back to the memory piece a bit. Like a lot of people think of agent memory as a form of personalization, but I actually think that one of the most interesting forms of agent memory is, to your point, making agents stateful, where it can start to keep track of how it solved problems before. Another thing that we see really often is the semantic cache. I hate the term semantic; it means a million different things, but semantic cache in this context means that context also means a million different things, but in this phrasing is that it will keep track of problems that's solved before. Someone asks a question that has a very similar intent, something that's been solved before someone else asked. You should be able to answer the same question. So there's a lot of things we can do to make these things much, much more efficient. And I think for most, if you're building an AI data analyst, sure, like everything that we've talked about here is going to be really relevant. But most people aren't, and most people are kind of building something else and then finding that AI data analyst technically solves this until you start thinking of security, you start thinking of cost, you start thinking of everything else around it.
Simba, are you guys building your semantic cache as a vector search?
Correct. Yeah, we have our own embedding model. We actually got our research team got published in iClear on it. But yeah, we have an intent-based embedding model.
Yeah, because token cost is like the new, runaway Snowflake cost.
Yeah, I mean, and now, with in Paul's world, like in Paul household, all the budget is between Dario and Ali, and they're kind of like getting all the money one after the other with all the agents. And I think this will be definitely a frontier for all data people soon. Is both the cost of tokens and and the efficiency, but also the cost of the underlying infrastructure in the OLAP world, where I mostly live. I think there's a new being aware that the old world of few humans making query, low concurrency, overcharges it was fine, but now this model can definitely not scale to this thing, and I think it will be like definitely top of mind for everybody. But with Simba defining the semantic of semantic and the context in context, I think we're confused enough to wrap this up. And I think we're like at the top of the hour. There's a few more questions from the audience. Guys, feel free to reach out to me and to all the speakers. They're very, not just handsome and very competent as they prove, but they're very, very nice humans, which is why we like to talk to them. And so feel free to ask your question directly. This will be available as a recording on our YouTube. And so stay tuned for more content of this type. Guys, Matthew, Paul, Simba, thanks so much for spending this hour with us and kind of like impart all the wisdom and all your hot takes on the semantic layer. And I'll see you, I guess, next time. I'll buy you a beer in Colorado, North Carolina, and Zurich or San Francisco next time we're around. And thanks everybody for joining us today. I hope you enjoyed it as much as I did. And of course, go Knicks. Ciao, guys.
Thanks.
Thanks all.
Thanks so much.
Thank
Bye.
you.
Have a good day. Bye.